Okay, so today we're in chapter 7.1, and we're going to talk about trig identities. So what we need to know about, let's recap everything that we know is true. Now, an identity is true for any value of the variable that we put in. So what do I mean by that? Well, for one thing, we know that the sine of alpha, we could rewrite that as 1 over the cosecant of alpha, and that'll be true for any angle alpha. Usually, though, it's more helpful when we do it the other way, that we say that the cosecant is 1 over the sine. We also then have the cosine of alpha. We could write that as 1 over the secant of alpha, or we could write the secant of alpha as 1 over the cosine of alpha. This is true for all values of alpha. We also have the tangent of alpha. Can be written as 1 over the cotangent, if necessary, of alpha. Or the cotangent could be written as 1 over the tangent of alpha. Okay. So these are 6 identities that are true. Okay. We also have a couple more for tangent and cotangent. Remember that the tangent of alpha can be written as the sine of alpha over the cosine of alpha. And then that the cotangent of alpha is equal to the cosine of alpha over the sine of alpha. So these are true. We have some even and odd properties. Remember that the sine of negative alpha, we could write that as the negative of the sine of alpha because it's odd. Now, since sine is odd, that also makes the cosecant odd. So the cosecant of a negative alpha, we could write as negative the cosecant of positive alpha. And then the tangent is also odd. So we could write that as negative tangent of positive alpha. And also then the cotangent is odd. We have 2 that are even then. We have the cosine. So the cosine of negative alpha, we can write as cosine of just positive alpha because it's even. And then similarly, because the cosecant is the reciprocal, not the cosecant, the secant. The secant of negative alpha is also odd. Right? Now, you'll need to know all of these identities. Okay? Remember, we have a few more also. We also have we have our Pythagorean identities that come directly from the circle. Remember that sine squared of alpha plus cosine squared of alpha must be equal to 1. That's our first form. Okay. Now we could also, I'll go through the derivation again so you guys remember how we do this. Okay, I could also choose to divide everything by sine squared. Of alpha, and so what we would get then, sine squared over sine squared is 1, plus cosine squared over sine squared is cotangent squared of alpha, and 1 over sine squared is cosecant squared alpha. Okay, so this is number 2. Okay, this is true for all values of alpha. Alternatively, though, we could also divide through our Pythagorean. We can divide this through now, instead of by sine squared, let's do it by cosine squared. And now sine squared over cosine squared is tangent squared, plus cosine squared over cosine squared is 1, and that's equal to 1 over the cosine squared is secant squared. So this is our third form of the Pythagorean identity. Okay. Alright, so that's what you need to know. So you can do these next problems. So let's say we wanted to simplify the cotangent of x divided by the cosecant of x. Okay. Well, one methodology for simplifying these things is to turn everything into sines and cosines. So if I do that, the cotangent of x is the cosine of x over the tangent of x. Okay. So that whole thing needs to be divided, the cosine over the sine of x. And here, the cosecant is 1 over the sine of x. Okay, so from here to here is true, just rewriting by identities. Now, we can simplify this, and we're just going to use some algebra. Here we have one fraction being divided by another fraction, and so when we divide fractions, we just have to invert and multiply. So this is now by the sine of x over 1. And canceling will still hold. The sine of x will cancel, and up top we'll just be left with the cosine of x. Okay. So we have simplified the cotangent of x divided by cosecant of x is really the same as just the cosine of x. Let's do another. Say, for example, what if we had to multiply the secant of alpha minus 1 and the secant of alpha plus 1? Okay. So here we're just doing multiplication. There's two binomials, and anytime we have that, we just simply FOIL. Okay. So secant of alpha and secant of alpha becomes secant squared of alpha. Okay. The outers is plus secant alpha. The inner is minus secant alpha. And then last is minus 1. Okay. So these two are equivalent. Now let's use some algebra and simplify this some more. The secant of alpha subtracting a secant of alpha, well, these just go to 0. Okay? So we're just left with secant squared alpha minus 1. Now anytime you see some secants or anything being squared, especially if they have 1's involved, you should be thinking about our Pythagorean identities. Okay, so as I scratch this off to the side, I know that sine squared plus cosine squared equals 1. I'm trying to find out what secant squared would be. Well, secant squared is 1 over the cosine, so let's divide everything by cosine squared. And now the identity that comes here is that tangent squared plus 1 is equal to secant squared. Okay. So notice I didn't have to memorize this, I just derived it, is what we call. Alright, so if this is secant squared, I'm going to replace it with over here. Secant squared is tangent squared of alpha plus 1. Okay, that is secant squared. And then from above, we're still subtracting 1. And now I can simplify this even more. 1 minus 1 goes to 0. And so we're simply left with tangent squared alpha. Let's try and write sine of x in terms of cosine. Okay, how are we going to do that? Well, let's start with something that we know to be true. We know that sine squared x plus cosine squared of x equals 1. We know that. Okay. Now we're going to try and write sine in terms of cosine. So I want to isolate the sign. So it is true then that the sine squared of x is equal to 1 minus cosine squared of x. I simply subtract cosine squared from both sides. Okay, good. Now, we've written sine squared in terms of cosine squared, but we're asked to find the sine of x, so let's take the square root of both sides. When we do this, the square root and the squaring will undo, so now we have just the sine of x is equal to, and let's not forget this, the plus or minus of the square root of 1 minus the cosine squared of x. And that will depend on our quadrant. So there's a couple in your homework that are like this, where they give you just a sine or a cosine or a secant and a cosecant, etc. So you'll want to start with this identity, maybe manipulate it to something like this, okay, and then solve. Okay, so let's simplify this one. If we had 1 over 1 plus the cosine of negative x, and we add 1 over 1 minus the cosine of positive x. Okay, so this is our job. We need to simplify this. Well, when you're given a fraction, we're going to have to add fractions. That's what we're going to have to do. Now, before we do that, let's simplify numerators and denominators. So the numerators are already simplified. I can simplify this one further, though. This becomes 1 over 1 plus, and now I know that the cosine is even, so the cosine of negative x is just the cosine of positive x. Okay. And there's not much to do over here, 1 minus the cosine of x. Okay. It doesn't matter if I put parentheses around or not. These are the same things. Okay. Well, if we're going to do this, to add fractions, we need a least common denominator. And in this case, it's the multiplication of the two. So I take the first one, 1 plus the cosine of x, and I multiply that by 1 minus the cosine of x. Okay? This is going to be the least common denominator. Which means over here, I need the 1 minus the cosine of x. And over here, I need the 1 plus the cosine of x. So now our denominator, now again, don't multiply these out quite yet. Let's see if we're even going to need to do that. We might have to, we might not. So our numerator over here is 1 minus the cosine of x. Then we're adding to that, this numerator, which is 1 plus the cosine of x. 1 Now again, simplifying as we go, 1 plus 1 equals 2, and minus cosine x plus cosine of x. These will go to 0. So we're at 2 over 1 plus cosine of x, 1 minus the cosine of x. Okay. Alright, now I'm thinking, let's see what happens when we multiply those denominators together. So this is equal to 2 over, and again when I multiply these I'm going to FOIL them, so we'll get 1, then minus a cosine of x plus a cosine of x, well those are going to go to 0, and then minus cosine squared of x. Remember to put what an x or an alpha or whatever angle, something to represent the angle, You don't want to just write 1 minus cosine squared. It's cosine squared of what? Okay. You would never write 1 minus square root and just leave it like that. It's square root of what? It doesn't make any sense. So make sure you put in the x. Okay. Alright, well, why was that helpful to us? Well, 1 minus the cosine squared, right? Remembering our sine squared plus cosine squared equals 1. Okay. So if I subtract cosine squared from both sides, I see that this is equal to sine squared. Okay. By the way, this is just scratch work, okay? When you're doing it, your problems, make sure you write everything out neatly. Okay, so 1 minus cosine squared is sine squared of x. Okay. And we could write this as 2 times 1 over sine squared of x. Okay, like 2 over 1. So if you multiply them back together, you're going to get this. Right, so why was that helpful? Well, 1 over sine squared of x is, well, the 2 stays, but sine squared, 1 over sine squared is cosecant squared x. So this is the simplification to our original problem. Here's another example. Let's determine if a function f of x that's equal to the tangent of x divided by x is even, odd, or neither. Okay, so when we do that, when we're looking for even and oddness, remember the first thing we do excuse me, is we evaluate the function at the negative angle. Okay, so f of negative x is equal to the tangent of negative x over negative x. Okay. Now let's start simplifying. Okay. Well, the tangent of negative x, tangent is odd, so this is the same thing as negative of the tangent of the positive angle, still over negative x. But when we do this, the negative and the negative will become positive. So this is just equal to the tangent of x over x. And that is equal to our original function. So, if when we evaluate the negative angle, if we get the original function back, then this is an even. So therefore this is an even function. Okay, let's try another one. Okay, so we're mixing algebra and trigonometry now. Example. Let's multiply the cotangent of x minus the cosecant of x times the cotangent of x plus the cosecant of x. Okay? So these are conjugates of one another. Right? So let's multiply these together. We'll get cotangent squared, we're going to FOIL, plus the cosecant cotangent minus the cosecant cotangent. That will go to 0. And then minus cosecant squared of x. Okay. Now, I'm thinking that I see lots of squaring going on. So let's go back to our original Pythagorean and do just a little scratch work over here. I'd like to get a cotangent. Okay. So for that to happen, a cotangent, I need cosine squared divided by sine squared. So I have to do that to everything. Okay. So this is 1 plus cotangent squared of x is equal to 1 over sine squared, which is cosecant squared of x. Okay, so cosecant squared is 1 plus cotangent squared. Alright, so let's put that in. Cotangent squared x, now minus from here, and then we're going to have to open up parentheses because I'm going to be subtracting off two different things. 1 plus cotangent squared. Now, we'll just bring the cotangent of x down, and remember to distribute that negative through to get minus 1 minus cotangent squared x. And now we can collect like terms, and so the cosine squared minus the cosine squared will go to 0, and we're simply left with a negative 1. We can also factor using trigonometric functions. So, for example, say we have cosine squared x minus cosine of x minus 6. So what we could do a u substitution here. So if we let u equal the cosine of x, then if we square both sides, u squared is equal to cosine squared of x. So that means this has the form, well, cosine squared is u squared, minus the cosine of x, which is just minus u, and then minus 6. So this will factor into minus 3 plus 2. But that's how the u's factor, and then we can just put what u is back in. U is the cosine of x, so we could factor their original into the cosine of x minus 3 and the cosine of x plus 2. So we can factor just as we would with variables. What if we had to simplify cosine cubed of x minus a cosine of x all over minus cosine of x? Okay, well, up top, I do have a greatest common factor, and that is of a cosine of x. So when I factor that out, I'm left with cosine squared x minus 1 over negative cosine of x. Now these cosines will cancel. Now I've got to be careful here. There's a negative here, so that's a negative 1. I still have this. So this is the cosine squared x minus 1 divided by negative 1. Well, I'd like to get rid of that negative 1 in the denominator, so I can multiply up top and down below. And the reason why I do that is a negative 1 and a negative 1 become a positive 1. Okay. Now when I multiply the negative through up top, we're going to get minus cosine squared of x plus 1. Alright, let's keep simplifying. Now anything over 1 is just itself. And I can also commute these. So this is really the same as 1 minus cosine squared of x. But I know that 1 minus cosine squared from our Pythagorean identities is equal to sine squared. So this expression will simplify just to sine squared. Okay, sometimes when we'll be given an identity, and we'll have to verify it. So for example, if we have the secant of x minus the cosine of x divided by the cosine of x, we are told that the identity is that it's the same thing as tangent squared of x. And it's our job to show why this is true. Now, the way we will do that is that we'll start with either the left-hand side or the right-hand side and manipulate it until we come to the other. Don't work both sides at the same time. I always choose to work with a side that's more complicated because there's a lot more for me to manipulate than, say, if I just started with tangent squared. Okay, so I'll abbreviate this LHS for the left-hand side. That's the side I want to start with. So let me just copy it down, and then we can think of a strategy. I'd like to do any sort of simplification that I can do. Let's see here. These are cosines. One strategy is to have everything in sines and cosines. Okay? So if we do that, then the secant of x is 1 over the cosine of x. And now I'm just going to copy everything else. Minus, and just to be clear, this is now the cosine of x over 1. And we'll divide by the cosine of x. And you can put that over 1 if you'd like as well. Okay. So this is as simplified as this can get. Up top, we could get a common denominator. Okay? And that common denominator will be the cosine of x, just 1 times the cosine of x. Alright. So, what we get then is our denominator stays the same, cosine of x over 1. We have the new denominator here, which is the cosine of x. So I'll take the 1 from here, and then minus cosine and cosine is cosine squared. Alright, now I have two fractions being divided, so I can invert and multiply. Alright, let's multiply these together. So we'll have one fraction. So up top is just 1 minus cosine squared. Okay. Down below, cosine and cosine multiplied together as cosine squared of x. Okay. Now remember where we're trying to get to. We're trying to get to tangent squared of x. Okay. Well, I know that 1 minus the cosine squared, I'm just copying the denominator now. Okay. But 1 minus cosine squared is sine squared of x. And now we're done. We've done it. Sine squared over cosine squared is tangent squared of x, and that's equal to the right-hand side of the equation, which is what we were trying to prove. Sine squared over cosine squared is tangent squared, which is the right-hand side of the equation, which is what we were trying to prove. Okay. Let's try another identity. Okay, 1 plus cosecant squared x cosine squared of x is equal to cosecant squared of x. Okay. Again, this is what we're trying to prove, that these two are equal. This side is more complicated, so I think I'll work with that first. I'll take the left-hand side. 1 plus cosecant squared of x cosine squared of x. Okay, so this is our left-hand side. And I'm tempted right now. There's a couple of things we can do. Let's change everything to sines and cosines. Okay, so cosecant squared, right, so this is equal to, we'll keep the 1. Now cosecant squared is 1 over sine squared, plus, don't forget that, 1 over sine squared, and that's still being multiplied by that cosine squared x, and if you want, you can think about that as over 1. So now putting this together, this becomes 1 plus cosine squared x over sine squared of x. Okay, but what is cosine squared over sine squared? Well, that's just cotangent squared, right? So we could write this as 1 plus cotangent squared of x. Okay. Now I'm trying to get to cosecant squared. I have 1 plus something squared, so I'm going to go back to our Pythagorean identity and do a little scratch work. We know sine squared plus cosine squared equals 1. I need a cotangent squared, so I need to divide everything by sine squared. This becomes 1 plus cotangent squared of x is equal to 1 over sine squared is cosecant. I'm running out of room squared. So that is this entire thing, 1 plus cotangent squared. Well, that does equal cosecant squared. And that is our right-hand side. And that is what we were trying to prove. Okay, let's try another one. Here's another technique that's going to be very helpful for you. Let's say 1 minus sine squared of x over 1 minus the sine of x. That's equal to cosecant of x plus 1 divided by the cosecant of x. Now when you're doing these, it's up to you to pick which side you want to work with, and sometimes you can work with one side and then change your mind and do another one. Okay? So for example, this is what I mean. Let's say I decided to work with the left-hand side. I might want to work with that because 1 minus sine squared will factor into 1 minus sine times 1 plus sine over 1 minus sine. Now, that was nice because then these will cancel, right? And now I'm left with 1 plus the sine of x, which is true. But how exactly am I going to manipulate this to get to that? Well, there's a couple different ways to go about this. If I do some scratch work up here, I could see that if I could get to something that said cosecant over cosecant plus 1 over cosecant, if I could get to this stage, cosecant, if I could get to something that looks like this, then I would be just a step away from here, because I could combine, then add the two fractions. Okay, well some of that won't be hard to do. Okay, well 1, that is just, we could rewrite that as cosecant of x over cosecant of x. And actually we are right there. The sine of x, we could write that as 1 over the cosecant using the reciprocal identity. So that goes here, and there's still a plus inside. And now we can see that cosecant, let's see, now we're trying to get to here, so this, we could just add the fractions together. Oh, sorry. Okay. From here, we have the common denominator, so we could write that as the cosecant of x, and then the first one's the cosecant of x plus 1. So sometimes you're going to have to get creative. We could have done it from the other side as well. Let's see what happens if we do it the other way. let's see if we had started with the cosecant of x plus 1 over the cosecant of x. Well, if I had started with the right-hand side, I may have been tempted to turn these into 1 over signs right away. Plus 1, and you can write 1 as 1 over 1 if you'd like. Okay, now we'll need a common denominator, which is sine. So our denominator will stay the same, 1 over the sine of x. Okay. And our numerator, this also is 1 over the sine, and then we'll take 1 plus 1 the sine. Just getting the common denominator. Okay, now we're multiplying fractions, or we're dividing fractions, so we will invert and multiply. And now these signs will cancel, and we have this 1 plus sine. Okay. Now, let me write where we were trying to get to. We're trying to get to 1 minus sine squared of x over 1 minus sine of x. Okay. Alright, well, let's think about it this way. This is always over 1. I need a denominator that says 1 minus the sine of x. So let's multiply by 1 minus the sine of x, because that'll get us to the denominator we need. And then we have to remember to do that to the numerator. Okay, so our denominator is 1 minus the sine of x. Okay. And now when we FOIL these, we'll get 1 minus the sine of x plus the sine of x will go away, and then minus sine squared. And that's exactly what we wanted, which was equal to the left-hand side, and so we were done. Let's do another one. Example, if we have negative 1 over the tangent of theta minus the secant of theta, and we have to show that's equal to 1 plus the sine of theta over the cosine of theta. So the left-hand side looks more complicated to me, and so I would like to start working with that. And I'm thinking that we will change, so let's see, the left-hand side is where we will start, which is negative 1 over the tangent of theta minus the secant of theta. So I'm thinking what we'll do is we'll change everything to sine and cosine, since that's what we have over here. Okay, so the tangent of theta is the sine of theta over the cosine of theta, then minus, and the secant of theta is 1 over the cosine. Okay. Alright, now let's simplify that denominator, because we have a common denominator of cosine. Okay. So this is sine of theta minus 1 now, over the cosine. Okay. Alright, so when we're dividing with fractions, let's invert and multiply. So what will we have? A negative cosine of theta up top over the sine of theta minus 1. Okay, so now we're kind of in a conundrum. I really would have liked to have seen this cosine of theta be in the denominator, because that's what we have. And I really would have liked this minus to be a plus, but that's not what we have. Well, let's multiply by a negative 1. Why not? Okay. So up top, that will give us a positive cosine of theta. And down below, we're going to have to distribute this, right, to both places. So we'll get minus sine of theta plus 1. That still didn't help us too much, but let's look at it a different way. This is the cosine of theta over, these two will commute, 1 minus the sine of theta. Okay, I need a cosine of theta in the denominator. Well, I know this. I know that 1 minus sine squared of theta is equal to cosine squared. So that's closer. And that I could get to 1 minus sine squared if I multiplied this denominator by 1 plus sine squared. Okay? That is, if I multiply by the conjugate, I'm going to get 1 minus sine squared. Okay? But I have to do that up top as well. So let's see what happens then. Okay? So this becomes the cosine of theta. I'm not going to distribute it through yet. 1 plus sine squared of theta. And this is 1 minus sine squared theta. Now the reason I'm not going to distribute this through is because I know that this is going to turn into cosine squared. So now the denominator is cosine squared theta. And our numerator is still cosine squared. No, I'm sorry, cosine of theta times 1 plus, I'm sorry, these shouldn't be sine squares, should they? 1 plus sine, sorry. So this is 1 plus sine. Sorry about that, you guys. We want to multiply by this conjugate. Okay. All right. Phew. So that's looking a lot more like what we want up here, this 1 plus sine theta. Okay. Now we're there, just 2 steps away. This cosine will cancel with one of the cosines. Okay. So in the end, in the numerator, all I have is that 1 plus sine of theta over the cosine of theta. Okay. And that is equal to our right-hand side, which is what we were trying to prove. Okay, so this technique of multiplying by the conjugate can get you a lot of places. So remember that when you're doing your homework. The only advice I have for you when you do this is make sure you know your identities. If you don't know your identities, that's going to be a problem doing these. And then just try, okay? And make sure, try something. Don't just stare at it. Just see where, whatever, you know, like for example here, just changing it to sines and cosines, getting your common denominator. Just see what's going to happen. Getting rid of negatives. And just see where the next steps go. And think about what you can do. Okay. So I think that will do it. Send me a question if you have any, or send me an email if you have a question. All right.